Hi, so today we're going to be going over question 2 from homework number 5 from fluid dynamics. So in this question, we're required to find the horizontal component of force to hold the plate stationary. So go ahead and take a second to read the question. And now we're going to go ahead and underline the information that we are given for this question. So we know that we're going to find f of x because that's the horizontal component. You can always reference a unit vector in case you get confused with the horizontal and vertical distance. And basically we're given it has a diameter of 330 millimeters, and we have a velocity of 35 meters per second, diameter of 80 for the second, and velocity of 35 and diameter of 20. Okay, so now that we're given that information, we're going to take the diagram here that we're given and we're going to write out a few things. So as we mentioned, we have mass flow rate here. We're going to have a velocity 1 here. We're going to divide this into 2 sections. So there's going to be 1, there's going to be 2, and you're going to have mass flow rate 2, velocity 2 here. And then remember, we're looking for this horizontal component of the force. So that we're going to go ahead and add right here. That's gonna be our f of x. So now that we went ahead and simplified this diagram, let's go ahead and write down our formulas. So this is going to be the summation of forces. So we're going to have f of x equal to, this is going in, this is going out, so we can reference as positive and negative. So mass flow rate 1, velocity 1, and this is going to be negative since it's flowing outwards. So that's what our equation simplifies down to. So let's go ahead and simplify it a little bit more. Remember that our mass flow rate is equal to density times velocity and our area. So as you can see, we can simplify this a little bit more. In this case, our density is going to be the same, so we can just take that out. Simplify that as well. Okay. So in this particular case, we also notice that our velocities are equal to each other, so 35 meters per second. So really, v1 equals to v2, which is the 35 meters per second. So we can also take that out. And let's go ahead and do that first before I get into something else. So 35, let's square that. So we're just left with a1 minus a2 on the inside of that. And another thing that we can do, you can just leave it like that and go ahead and just add the values. Remember that your area is going to be 2 pi 4 diameter squared. What you can do is just take out the pi 4th into this and put it here, or you can just plug it in straight into your area. So what I'm going to do is I'm going to take out that value and just put it in the front. So p velocity squared pi 4th and diameter 1 squared minus diameter 2 squared. So now I'm going to just go ahead and plug in all of the values. So our density for this one is going to be 1.23. I keep filling that out. Diameter 1, remember we were given that to be, let's go back here. Diameter 1, this is going to be our diameter 2. So in this case, we are given diameter 1 to be 80 millimeters. We're going to go ahead and convert this to meters. So that's just going to be right there. So basically that's this, right? Or that's 0.08 meters. And then that's going to be cubed. So go ahead. You do the same for the other one. Diameter 2 is going to be 20 millimeters. So go ahead. That's 0.02 meters. So So let's go ahead and do that. And remember that this is all gonna be squared. Sorry, I realize I put a square here. And let's go ahead and simplify that. Make sure that you put everything in. Yes. Okay, now we take our calculator. We have 1.23 5 35 8 0.0 times 35. Okay, so we get our horizontal component, or our f of x, is going to be equal to 7.1 or 7.10 newtons. Okay, so that's going to be it. Let me know if you have any questions in the comments.